Okay, so have you ever looked at code, like lines of code, and just thought, what is this? This is like hieroglyphics.
It can feel that way, right? Like a secret language.
Totally, it's intimidating. But that's what we're doing today. We are cracking the code, literally.
Decoding the mysteries of the digital world. You ready?
I am so ready. And it gets even better, get this. Our source material today is Fundamentals of Programming 1, but it's in Arabic.
Ooh, a challenge.
So we're talking double whammy here. We are translating the Arabic A&D, trying to break down these programming concepts. It's like we've stumbled on some ancient scroll.
Right.
Except instead of finding, a lost civilization,
Yeah.
we are going to decode the language of computers.
I love that. And what's interesting is for a book about computers, this one really focuses on like the human side of things. They have this whole concept of hardware.
Hardware. Okay, now that is not a term I've ever heard before, and it sounds way more like philosophy than programming.
It's a really interesting concept. Basically, they're talking about the human mind, the programmer's mind,
Oh.
as the source of all these ideas and the logic behind programming.
So before a line of code is even written down somewhere,
Exactly.
that initial spark, that initial idea is hardware.
It's the blueprint. You
Wow.
have an idea, a plan, that's your hardware. That's what they call hardware.
Okay, I mean, I'm already seeing why that's important.
Mm-hmm.
Because if you don't have that clear vision from the get-go, how are you going to make something?
And you can have all the technical skills, but if you don't have that initial thought process, that clear hardware phase, your code's going to be a mess.
It's going to be a jumbled mess. That's like trying to build a house without blueprints.
Yeah.
It's just like chaos.
Exactly. And that's where understanding the fundamentals comes in. Like this book goes into detail defining things like system,
Right.
which in Arabic is hu,
Mm.
and computer, which translates to if. And it might seem basic, but you have to define the building blocks.
So even though this is in Arabic, even though we're dealing with kind of these like big picture philosophical programming concepts, it still starts with the nuts and bolts.
Because you need to understand how the computer works. You have to understand how it processes information to give it the right instructions. And those instructions are the software.
Okay, so we've got hardware, our big idea. We know the system, the computer, what we're working with. How do we translate all of that blueprint in our brain into something that a computer actually understands?
That is the magic of software, right?
Yes.
And that's where it gets really interesting because it's like this chain reaction. It starts with your thought process, goes into lines of code, and then it triggers actions on your computer.
Okay, so we've got this chain reaction you're talking about
Right.
from the hardware, this idea,
Yeah,
to an actual action on my computer.
exactly.
But what are the steps in between? Is there like a step-by-step guide in this Arabic scroll?
Yeah, there is.
Okay.
There is. And they lay it out really clearly, like in this hierarchy.
Okay.
And luckily, they use flowcharts. So for visual learners like me,
Ooh, flowcharts.
it's real.
Now you're talking my language.
Right.
Flowcharts, yeah, that makes sense.
So it shows how your thought, like your initial thought, your hardware inspiration, goes to this process and how the computer understands that and then acts on it.
Okay, I'm ready.
Right.
Give me the step-by-step.
So first, you have your human thought, right? That's that blueprint in your mind.
Okay.
And you take that thought, and then it turns into what we call source code, and that's using a programming language.
Okay.
So you're basically writing down your idea.
So it's like translating it.
Yeah,
Translating it into a language the computer can understand.
exactly, yeah.
Okay, so I've got my source code.
Okay,
But computers are notoriously literal.
right.
What happens next?
So that's where these things called compilers and interpreters come in.
Interpreters?
Yeah.
Like I need a UN translator for my code.
Basically,
Okay.
they take your source code and then turn that into something called object code,
Okay.
which is what the computer hardware actually understands.
So is it fair to say that like the source code is speaking English, my computer's speaking binary,
Yeah.
and the compiler or interpreter is like fluent in both?
Exactly.
Okay.
It's translating so the computer knows what to do.
Gotcha.
Otherwise, it would just be like, what is this?
It would be very confused.
Exactly.
Okay, this is starting to make sense now.
Good.
We go from the hardware to the source code to, with the help of a compiler or interpreter, object code.
Right.
Then what? What's the final step here?
And then the computer takes that object code
Okay.
and turns it into actions. So like your website loads or your game, your character junks or your spreadsheet calculates.
Yeah.
It's all because of this chain reaction.
So it all comes back to that.
It does.
That's kind of amazing.
It is really cool.
It makes it feel less magical and more like, okay, these are the steps.
It's a process.
And if I understand these steps and how they work together,
Right.
I can do this.
Exactly, yeah. And that's where choosing the right tools, like the programming languages, that comes in.
Okay, so let's talk about the languages then.
Okay.
Because it feels like there's like a million of them.
There are a lot, yeah.
Do I need to learn all of them?
That's where it gets a little less overwhelming because think of it this way. You don't have to be like a polyglot and speak every language
Oh,
to appreciate different languages.
That's true.
Yeah,
I can barely order coffee in another language, but I can appreciate
right.
that it's beautiful, it's different, it's complex.
Yeah, exactly. And it's the same with programming languages. Like
Okay.
some are meant for different things. Some are definitely more beginner friendly than others.
Mm.
And this book actually goes through, it's interesting because it goes through the evolution of programming languages.
Oh, really?
Yeah.
Okay, so like we started with cave drawings and then went to hieroglyphics and now we have like emojis.
Basically. So
Some
like
are-
in the really early days, it was machine language.
Okay.
And that was literally just ones and zeros.
Oh my gosh.
Can you imagine writing an entire program with just ones and zeros?
My brain hurts just thinking about it.
It's a lot. So thankfully, then they came up with assembly language, which was a little bit of a step up.
Okay.
They used like some human readable commands, but it was still very, very cryptic.
Okay, so if machine language was like grunting to communicate,
Huh?
assembly language was like very short sentences.
Right, exactly.
Okay.
And then it went from there.
Okay, what was next?
Yeah.
Did we finally get to like full-blown novels?
Yes, basically like high-level languages is what they call it.
High-level language.
Yeah, like C, Pascal, Basic.
Oh, okay, those are familiar.
You've heard of these, right?
Yeah.
So those are much more user-friendly, and they use syntax that kind of looks like resembles human language.
So instead of needing like the secret decoder ring,
Mhm.
it's more like I can pick up like a travel phrase book
Right, exactly.
and be like, okay, I can kind of figure this out.
Yeah, it bridges the gap between like our human thinking and what the computer can actually execute.
That makes sense.
And so you pick, just like you would pick the right phrase book for the right, you know.
Right. If I'm going to Italy, I'm not going to bring my Spanish phrase book.
Exactly, right.
You're going to pick the right programming language based on what you're trying to build.
Okay, this is all making so much more sense now.
Good.
I'm starting to think like maybe I could do this.
Yes, you can.
But let's talk about the actual writing of the code.
Okay.
We've defined the problem, we've chosen our language.
Right.
Where do I even start?
Yeah. And thankfully, this book lays out a really nice, like, it's almost like a roadmap
Okay.
to go from that initial hardware spark to functional code.
All right, hit me with this roadmap. Okay, so the first step, they really emphasize this in the book, is defining the problem,
Okay.
which might seem kind of obvious,
Okay.
but you would be surprised at how many people just jump into coding without actually figuring out what they're trying to solve.
Oh, interesting. Okay.
Yeah, so it's like setting out on a journey without knowing your destination.
You just get in the car and start driving.
Exactly. You're just like, I'm going.
Right. Right.
And you might end up somewhere, but it's probably not going to be where you want to be.
Exactly. Exactly.
So once you know what you're trying to achieve,
Okay.
you break down that problem into smaller steps.
So like a recipe, almost.
Yes, exactly.
Okay.
You're not just going to throw all the ingredients into a bowl at once and hope for the best, right?
Right. Exactly.
So you're going to create a plan of attack, figure out the logic of how you're going to solve this step by step.
Okay.
And that leads to the next stage, which is designing your solution.
Okay.
And so that's where you choose, okay, what programming language am I going to use? What tools am I going to use? What is my overall approach going to be?
So it's like putting on my architect hat.
Yeah.
Okay.
And figuring out like the blueprint for my code.
Got it. Okay.
And that's where those different programming styles we talked about earlier kind of come into play. Like,
Yeah.
are you going to do something that's more procedural, where it's like step by step, like a recipe?
Right.
Or are you going to do something that's more object-oriented, where you're thinking about reusable blocks of code?
Okay. So now it's like choose your own adventure time.
Exactly.
I like it. Okay.
All right, so now you've got your plan, you've designed it out, now it's time to program.
Okay.
So you actually have to translate that design into the actual code using the syntax of whatever language you chose.
syntax. That's where all those scary symbols and punctuation marks come in, right?
That is part of it, yes.
Oh.
Think of it like grammar
Right.
for your code, because each language has its own rules, and
Yeah.
if you don't follow those rules correctly,
Right.
it's not going to work.
It's like high school English class all over again.
Exactly.
Except instead of diagramming sentences, I'm trying to, like, wrangle semicolons and
Hey,
parentheses.
I'm so glad I don't have to do that anymore.
Oh, it's a good time.
But that's where practice and patience really comes in.
Okay, so let's say I've written my code, I've conquered the syntax demons. Can I hit run now and be done with it?
Not quite,
Okay,
because remember, programming is iterative.
okay.
It's a lot of trial and error, so the book talks about, like, implementation and testing.
Okay.
So you have to actually run your code and see if it does what you wanted it to do.
So this is where the debugging comes in.
Yes,
Yeah.
exactly. Which is, honestly, most programmers will tell you that's the bulk of the work.
Really?
Yeah.
I always pictured, like, the Matrix, just line after line of code.
You think it's very glamorous?
Yes. Like, furiously typing.
Great, like I'm in the zone coding and then
Yeah.
done. No, not really how it works.
So you spend more time fixing errors than you do actually writing the initial code.
Most of the time, yeah.
Interesting. Wow.
It's all part of the process.
Okay, so I've debugged, I've tested it, retested it. Is this the finish line? Are we there yet?
We're getting there. We're getting there. So the book calls it program execution.
Ooh, fancy.
Right. So that's basically where your code comes to life and starts doing what you programmed it to do.
So whether it's something as simple as a script that I've written to automate something,
Right.
or it's, some big complex program that's going to change the world,
Yeah.
it all comes down to this.
It all boils down to those lines of code.
Those lines of code, wow.
It is pretty powerful stuff.
It is powerful. Okay. It is powerful stuff. Okay, so we've talked about this whole process, this roadmap
Right.
of how to write code, how to think about code.
Yeah.
But this book that we're looking at, this Arabic programming book, they
Right.
call this whole thing, this whole idea, the programming process.
Mm.
So they break it down into 6 key steps.
Okay.
Are you ready to walk through these?
Yeah, let's do it.
Okay, so step 1, we kind of already touched on, but it's problem analysis.
Right.
So before you even think about opening up your laptop,
Right.
what is the problem you were trying to solve?
Exactly. And this is where, again, that hardware comes in,
Yeah,
because it's really about understanding the ins and outs of the problem.
Okay, so really wrapping your brain around it.
Yes, exactly.
Okay, so we've analyzed the problem.
Okay.
We know what we're trying to solve.
Right.
What's next?
So then we move on to step 2, which is defining the solution.
Okay, so this is where we start thinking about, like, okay, how are we actually going to tackle this?
Exactly. And it can be really helpful to break it down into smaller steps.
Okay, so it's that, like, divide and conquer kind of thing.
Exactly, yeah. Break it down into manageable chunks.
Okay, I like it.
So you're not overwhelmed by the enormity of the problem.
Okay, so we've analyzed the problem, we've defined the solution.
Right.
What is step 3?
Step 3 is algorithm design.
Algorithm. Okay, that's a word that gets thrown around a lot, but what does it actually mean?
So an algorithm is basically a set of instructions
Okay.
that tells the computer how to solve the problem.
Okay.
It's like a recipe that the computer can follow.
Okay, I like that. It's a good analogy.
Yeah, and there might be multiple algorithms you can use to solve the same problem.
Right, there's more than one way to bake a cake.
Exactly.
Okay, so we've analyzed the problem, we've defined our solution, we have designed our recipe, our algorithm.
Yes.
What's next?
So now we move on to step 4, which is coding.
Okay, this is where we actually get to write the code, right?
Yes, this is where the rubber meets the road.
Okay.
You take your algorithm, that set of instructions,
Right.
and you translate it into a programming language that the computer can understand.
Okay.
And this is where things can get a little bit tricky, because you have to make sure your syntax is correct.
Right. No typos.
Exactly, because even a small typo can cause errors in your code.
Okay, so we've got to be really careful, really precise.
Yes, precision is key in coding.
Okay, so we've analyzed, we've defined, we've designed, we've coded.
We're getting there.
What is step 5?
Step 5 is testing and debugging.
Okay, so this is where we make sure everything actually works.
Exactly. So you run your code, you see if it does what it's supposed to do, and if it doesn't, then you have to go back and debug it, which means finding and fixing the errors.
Right, because as we talked about, this is probably where we spend most of our time, right?
Unfortunately, yes.
Okay.
But it's an important step because you want to make sure your program is working correctly.
We want to make sure our cake is fully baked.
Exactly.
Okay, so we have analyzed, defined, designed, coded, tested, debugged.
We're on the final step.
This is it.
Step 6,
Documentation.
documentation. Okay, so this is where we write down everything we did, right?
Yes, essentially you're creating a user manual for your code.
Okay.
so that if someone else needs to understand it, or if you need to come back to it later on, you can easily figure out what you did and why.
Right, because if I look back at code that I wrote even like a week ago, I'm like, what is this?
So it's really for our future selves as much as it is for anyone else.
Exactly. Documentation is your friend.
Okay, so there you have it.
The 6 steps.
6 steps to becoming a programmer, as outlined by our Arabic programming friends.
Exactly.
Who knew that translating an Arabic programming book would open up like a whole new world of understanding about how we think about programming?
It's fascinating, isn't it?
It really is.
How universal these concepts are.
Yeah, and I think it really highlights that programming at its core is about problem solving.
Absolutely.
It's about taking a problem, breaking it down, and using these tools, these languages,
Yeah.
to come up with a solution.
And it all starts with that spark of hardware.
There it is again, that hardware. That's what I'm taking away from this whole thing.
It's the foundation.
It really is. So no matter what language you're coding in, no matter what problem you're trying to solve,
Right.
it all starts with that idea, that passion, that desire to create something new.
And who knows what amazing things you'll create.
Exactly. So get out there, find a problem that excites you, and start coding.